Good morning, pre-algebra. Here is your video instruction today. Please go to page 433 in your textbook. That will go to the example problems. Remember to watch these carefully. Give me some feedback too. If I'm going too fast in the video, you gotta tell me, because I make these videos ahead of time. You can't really say, go slower, and yell at the video, because obviously I'm not going to change because I've already recorded it. You can't do that. You don't have that power over me. But yeah, let me know feedback if it's too fast, too slow. Mr. T just writes stuff down, don't talk as much. That's helpful feedback. Remember, put it in a nice tone. That always helps. But while you're turning to the page, please listen to this joke. So here we go. What did the elder chimney say to the younger chimney? What? You're too young to smoke. Oh, got it. Good. Alright. Today we're talking about a concept which is called slope. Like, you ever heard, like, oh, I'm hitting the ski slope. Like, the slope means the angle of the slope of a line. How steep is it? That's what we're measuring. How steep is our angle or our line on a graph? So slope equals the rise over the run, or another way to put it is the vertical change over the horizontal change. Now, some of you may be thinking, wait, this sounds very similar to rate of change. You're right. It's very similar. You set up the problem very similarly, but we're not comparing two different things. We're really just talking about how steep is the line. So the way that we find both mathematically are the same, but it's a different concept. It's really measuring how steep is our line. So we're talking about vertical change over horizontal change, and we really set up our problems the same way. So we're going to look at example number 1 in your book. We're talking about a skateboard ramp, and I drew it right here. And it says, find the slope of the portable skateboard ramp that rises 15 inches for every 54 inches. So see, we're not comparing two different things, but actually we have the same kind of units. We have inches. So if I set this up, rise over run, so I'm going to say we're going to do 15 over 54. Did I get the right number? Yeah, 15 over 54. So both of those can be divided by 3, and you would get 5 over 18. And that's our number. And you could put that as a decimal. As a decimal, that would be 0.28. And that's our final answer. That would be the slope of our line. That's how steep it is. So really, that's all it is. If you're given a problem where they just give you the numbers of finding your slope, you just plug them in, and you get 5 over 18. Make sure you do the rise, which is your y, and then the run is your x. So that will help set up your problem for when we look at a graph. So I want to do one more example. I'm looking at 1a, and it says, what is the slope of a wheelchair ramp that rises 2 inches for every horizontal change of 24 inches? Write a fraction in simplest form. So it says it rises 2 inches, so rising would be my y, or the top, for every 24 inches that it goes horizontally. So we simplify that down to 1/12. And that is our final answer. So for some of your problems, that's exactly what it's going to be like. They give you your rise and your run, and you just plug it into your equation right up here, and you get the final answer. Okay? Some other problems, however, will be asking you to find it from a graph. So here, oh, I didn't write my lines in. Yeah, I'm going to do that real quick. Ah, look at that. They magically appear. Alright, so we're going to be finding our rise and our run, and again, we set up our problems the same way. So here on the left side, we're looking at letter A. We're looking at A. It says, find the slope of each line. So we're finding the differences between 2 points. So right here we have our point at 4, 3, and then we have our point at 8, 6. So all we have to do is really just find our rise, and then we'll find our run. So I'm going to start at this point at 0.43, and I'm going to count up. So we go up 1, 2, 3. So I'm going to write 3. We go over to the right, 1, 2, 3, 4. So I'm going to write 4. So our rise is 3, and then we have 3 over 4. So that's our final answer. We can't simplify it anymore. You could write it as a decimal, 0.75, but we can keep it as a fraction. All right, so now let's look at 2b. That's also in your textbook. So we count over, we go up 1, 2, 3, 4. So we have 4. Now here's the tricky thing. 1, 2. Now, did I go a positive 2 or a negative 2? Well, I actually went negative, so I have to make sure I record that. So our rise is a positive 4, and our run, our x, is a negative 2. So when we simplify that, a positive 4 divided by a negative 2 equals a negative 2, a negative number. So make sure you watch out for something like that you really watch which way your x's and your y's go. Typically, your rise is going to be positive, and then you'll find out if your run is negative or positive. That's typically how you find it out. Okay, so that's our problem of finding rise and run, our slope, looking at a graph. And now we're going to do something a little bit more similar. So I'm going to skip on down to our blank one. Now it says, what if we don't actually have a graph and they don't actually tell us the rise and the run, but they give us 2 intercept points? So this is where our equation that I've already kind of spilled the beans about, y2 minus y1 over x2 minus x1. This equals slope. This is how we can also find our slope if we're not given a graph or if they don't actually tell us the rise and the run. So let's try it out. I'm looking at example number 3, and it says find the slope of the line that passes through negative 2, 3, and then 4, negative 1. Okay, so now we have our intercepts. All I have to do is plug them into our equation. So our second y, let's label these real quick. y2, x2, y1, x1. So you can label them if you want, or you can just skip past that. But that just helps me organize. So I know I'm going to have negative 1 minus 3, and then I have 4 minus negative 2. Just double checking. Okay, yep, that's right. So I know I'm going to have negative 1 minus 3. That's really saying negative 1 plus negative 3. So we're going to have negative 4 on the top. However, when we have these two negative signs right by each other, that actually turns it positive. So it really means 4 plus 2. So 4 plus 2 is 6. So I can simplify that down to negative 2/3. And there is our final slope. Just double checking my answer, and that's correct. So that's our slope formula. If you're given 2 intercepts, you can do that problem. So now here's another example. Another example would be 3a at the very bottom of the page. Okay, and it says we have the points negative 4, 3, and then we have 1, 2. Okay, so plugging this in, I have 2 minus 3, and then I have 1 minus negative 4. So I end up with negative 1 over 1 plus 4, which is 5, negative 1/5. Okay, that's really plugging in your equations and finding answers. So one last thing, skip over to example number 4 on the page. Actually, we're going to go back to this page. And they've given you a line, 2 different lines, and I want you to just kind of look at them. So for example A, we're set at we're passing through the line at 4. So we have a horizontal line like this. And then we have a vertical line like this. So if you were to pick points, they've picked points for you on this graph, you're going to find some interesting things. When we look at the horizontal line, if you were to plug that into your y2 minus y1 kind of equation, we're going to end up with a slope that equals 0. It's going to end up with something like 0 over something on the bottom. So your slope, whenever you have 0 at the top, the slope is automatically 0. 0 divided by anything equals 0. So whenever you see a horizontal line, the slope always equals 0. However, you'd think that with a straight up and down, it would also equal 0, but we have something else. When you plug in your problem, you're actually going to end up with x something over 0. And you can't actually divide any number by 0. So when you see a straight up and down vertical line, the slope equals something called undefined. And, alright, we made it. Undefined. That's what we write. It is undefined. We can't actually divide any number by 0. That's when you get to some really weird mathematics that is way above my level of understanding. So straight up and down, slope equals undefined. Horizontal, across, straight, slope equals 0. Okay? If you want to do the math to find that, you can. They have that proven theorem of the y2 minus y1 divided by x2 minus x1, and that gets it. But we've hit 12 minutes. I gotta go, and you probably want to move on and start working. Work hard, ask questions. I'll see you in real life.